In this problem, we are asked to solve for ZL and the maximum average power transfer. Now, in dealing with this kind of problems, you have to recall about Thevenin's theorem, wherein you have to determine the equivalent impedance at specific part, and I'm referring to ZL, and also with ZL, under ZL, you have to determine the VTH, or the open circuit impedance in that particular part of the circuit where ZL is installed. And also, you have to recall always that the maximum average power transfer is equal to VTH magnitude squared all over 8 ZL, where ZL is equal to ZTH, the Thevenin's equivalent impedance. Okay, let's begin with the solution. Now, let's solve first for ZTH. Okay, so ZTH So let's disable the source. So our circuit now will look like this. So this is negative J10 and 30, 40 ohms and J20. So at this part of the circuit, it's where ZL or ZTH is installed. Where initially the ZL was being detached from the circuit. Okay, so let's solve for the equivalent impedance. ZL is equal to, okay, we have 30 minus J10 in parallel with 40 plus J20, and the result for this ZL is equal to 20 ohms. Answer. And now for VTH, the open circuit voltage where ZL is installed. So let's just redraw the circuit. Okay, so I will denote this as VA and VB. So my condition for this circuit is that VA minus VB is equal to VTH. So I'll just put here the plus and minus sign. Okay, so the easiest ways to solve for the voltages would be, I think, current division. So this is IA, and this is IB. Okay, if I would say that this node is my ground, that means that VA would be the voltage drop of this 40 ohm resistor and the voltage drop of this J20 ohm inductor for VB. So I will solve first for the branch currents. So IA, it's 2 angle 90 times the opposite, we have 30 plus J20. Sorry. Plus J20 over 30 plus J20 plus 40 minus J10. So our result for IA would be 1.02 angle 115.56 amperes. And by KCL, at node O, let's say node O, so if this is node O, therefore IB is equal to 2 angle 90 minus IA. So IB is equal to 1.166 angle 67.834. This amperes. And so we have VA equals 40 times IA. So VA is equal to, I have here 40.8 angle 115.56 volts, and VB, it's IB times J20. So VB is equal to 23.324 angle 157.834 degrees voltage. And finally, we have VTH is equal to, from the condition, VA minus VB, and so VTH is equal to 28.291 angle 81.878 degrees volts. And therefore our Pmax, from the equation we have 28.291 squared all over 8 times 20. Now remember that the VTH, only consider its magnitude value, do not include the phase angle. And so Pmax is equal to 5 watts. Answer.